Yeah, so let me address that last question first in terms of mobility. We're designing our systems to be one or two person lift. And we already demonstrated this back in 2000, what was it? 2022 with the Marine Corps at Camp Lejeune, the HTOP project, where we had our system in probably 3 or 4 Pelican cases, each one of which could be offloaded by one or two Marines off the back of a truck and then assembled in 15 minutes to operate. The moonshine hydrogen reactor, the kegs, right, those only weigh 20 pounds each. Uh, and then the cases weigh maybe 50 or 60 pounds. So the system is designed to be highly mobile. That's what we mean by exhibitionary infrastructure. Right? This is quote unquote infrastructure that's intended to be very mobile and lightweight. Some people have expressed a desire to not have to do the interconnections in terms of hoses and wires. And so we've also looked at putting it on a trailer because the entire system all together is less than 200 pounds. So something that we can very easily put on a trailer, such that it's kind of plug and play, ready to go once it's rolled onto the site. In terms of cost, we are right now working through those numbers. There are a couple different options, especially for the high pressure reactor. You can either get a very inexpensive steel pressure vessel that doesn't cost very much as the reactor, or you can put weighs a bit more, or you can use a COPV as a reactor, which is much lighter weight, but perhaps a little more expensive. So I think the price point is going to be kind of uh, two different levels. For the lighter weight, even more mobile systems, we're pricing it to be less than the cost, by half the cost of a Group 2 drone, such that a industrial or male-trained user can get a UAS, a full system. So that would be 2 drones plus our reactor, at only a 25% increase in the total system cost. And then for the, let's say, perhaps lower cost systems like the one that you're developing, probably be about the same actually cost at years then. Such that it can be scalable.
Okay. Because the logistics that I'm thinking through is, uh, if we're gonna put it on a trailer. I mean, you know that, for our use case, commercial customers who are using a hydrogen drone, say for inspection of power lines or pipelines or something in the States, you'll have a trailer that's pulling the drone. It's pulling compressed hydrogen cylinders that go in the drone, and then you'll either have their compressor and you'll have fuel cells, or you would replace those fuel cells and the vat of water with your system.
And the compressor,
Uh,
you can replace the compressor as well.
yeah, that's right.
Yeah.